Let's start with the first question. True or false? Computer vision is the study of how to make computers see. Let's answer some questions on the previous part. The current technology application directions of artificial intelligence mainly include which of the following is not an application of speech processing? The next question is true or false. Voice recognition refers to conversion of audio data to text data. Is this true or false? The phases of AI, also known as the stages of AI. The three stages of artificial intelligence include computational intelligence, space, and cognitive intelligence. Which is the third one?
Hello and welcome back to our Huawei HCIA-AI Exam Preparation series, a series in which we study mock exam questions to excel at the certification exam, while also learning the fundamentals of AI and machine learning from scratch. As we explained in the series introduction video, we adopt an active learning style by solving and explaining questions collected from mock tests and exams. However, the questions follow the same order as the preparation material provided by Huawei. We will study and explain each chapter with a progressive flow, building upon knowledge in sequential order, progressing through the training material to ensure a comprehensive understanding of AI and machine learning, while preparing for the exam by practicing the exam questions. Today we will continue with the second part of Chapter 1, AI Overview. But first, let me give you a brief introduction about who we are. 591lab.com is the top IT training and certification exam brand in China, Hong Kong, Taiwan, and Singapore. Our mission at 591lab.com is to provide you with exceptional exam preparation experience for certifications in Cisco, Huawei, Aruba, Juniper, Palo Alto, Fortinet, and many other exam tracks. The agenda of this video. In this video, we will cover the technical fields and application fields of AI and the phases of AI. Let's start with the first question. True or false? Computer vision is the study of how to make computers see. This one is very intuitive, of course, yeah. Computer vision is about how computers see. Let's explore together the popular subfields of AI, the technical ones and the application areas. We can find here content review, machine learning, computer vision, NLP, natural language processing, big data, expert system, database technology, integrated circuit design, object detection, autonomous driving, machine translation, medical imaging, intelligent customer service. All these are subfields or application areas of AI and machine learning. And of course, machine learning, it overlaps with all these fields. It's either used in other fields, or it is a field of, or it is the whole field itself. So for some fields, machine learning is the only method or technique that is used, and for others like natural language processing, you can use machine learning for natural language processing, and you can do natural language processing without machine learning. Both are AIs or different techniques of AI, and both are considered a subfield of AI. This diagram here divides the techniques and methodologies of AI and machine learning into subcategories and then into bigger categories based on the development stage. So it starts with the very basics, the algorithm. You have decision tree, support vector machine, random forests. These are names of some of the algorithms used in machine learning and AI. And then we move from the smaller circle into the bigger circle, which is research methods or schools. You can think of this as approaches to apply the algorithms. Some of the approaches or some of the schools are symbolism, analogizers, Bayesian, evolutionism. And then using these schools or these approaches and using the algorithms, you apply it to different AI technology fields or AI subfields based on your target or the task that you want to do, whether it's computer vision or natural language processing, robotics, or you want to build the expert system. Up to this point, it's still not a final product, it's not a real life application. So you apply all this in the area or the field that you want to create the application or the real life use. You can do it in smart manufacturing, smart finance, smart healthcare system, smart city, autonomous driving. This is like the final product, the area of application. The biggest circle is like the final product. Currently, AI technologies are mainly used in three main areas. These are the three main areas of AI. The first one is computer vision, the second one is speech processing, and the third one is natural language processing, or NLP. Computer vision is about teaching computers how to see, how to recognize objects, and how to see photos and other. We will go in details about this one. Speech processing involves various technologies for understanding speech, recognizing speech patterns, synthesizing speech, and perceiving speech. Synthesizing means producing voice and speech, producing heard speech like voice. Okay, so you give it text and it reads it out loud. It doesn't understand what it says, but it converts it from text to speech, or vice versa. It converts voice and sound into text. So this one doesn't mean that it understands the language, but the main task of it is to convert text to speech and convert speech or voice into text. The one that is concerned with understanding the language, what it means, is natural language processing. So this field focuses on using computers to understand and work with human language. Computer vision. Computer vision is highly developed among AI technologies. Main research areas include image classification, target detection, segmentation, tracking, OCR, and facial recognition. So we all know facial recognition is the one we use for opening our mobile phones. You unlock your phone with your face. This is facial recognition. OCR is the ability of a machine to see the letters in a photo or the text in a photo, like this one here. It scans the document and converts it into text, not just take a photo of it. Also similar to when you take a photo with your phone and then you extract the text from the photo. This is OCR. OCR is short for optical character recognition. Tracking, when you track an object in a video or a photo. Segmentation and target detection and image classification, all we can see here. So this is classification. The machine sees a photo and it classifies it into an object. This is a cat, or this is a photo of a dog, or this is a photo of a human. Semantic segmentation is dividing the photo into its objects, its components. Instance segmentation, it extracts the instance from the photo. Here you can see the dog and the cat are segmented in the photo. Object detection is recognizing the object inside the photo. It recognizes the dog, two dogs and one cat. So this is object detection. And this is instance segmentation. It extracts the whole object from the photo. And this is the semantic segmentation. It divides the photo into its components. and we already went through the classification. Back. Future expectations. The future expectations include autonomous understanding, analysis, and decision making, enhancing applications like unmanned vehicles and smart homes. I think that autonomous understanding and analysis has already been achieved. Recently there have been a few models that can understand photos and analyze it. I have also recently watched a video by Marcus Brownlee, a famous YouTuber. He's a tech reviewer. He did a review on a new model of Tesla car. It can do almost everything in unmanned vehicles, autonomous driving, but in some scenarios cannot handle. So it gives back the wheel or the control to the driver to drive himself. So you can argue that it's almost there, the unmanned vehicles and autonomous driving. Some of the application scenarios are electronic attendance and traffic analysis. Electronic attendance, basically you put a camera in the work or school or university, and it can take attendance with the facial recognition or any means of analysis for the attendees. Traffic analysis, you can also use cameras to track and analyze the traffic. And some other computer vision application scenarios are authentication and image search. Authentication, same thing as facial recognition for unlocking your phone, and image search is by uploading your image and search for it in the web. Voice processing. Voice processing is also called speech processing or speech recognition or automatic speech recognition. All these are synonyms to the same thing. Voice processing research encompasses various topics such as voice recognition, synthesis, wake-up, voice print recognition, and audio-based incident detection. Voice recognition is straightforward and easy. This recognizes a voice and transform it into text or any other task by recognizing the voice. Synthesis is the generation of voice. An example of this is when you hit the speaker button in Google Translate and it pronounces the word for you. This is synthesis. Wake up refers to the wake up call in some of the applications like Siri or in Alexa devices or Google Home. When you say hey Google, or Alexa or hey Siri, these are called wake up calls. I know in Alexa and in Google devices they have edge computing. So these devices aren't supposed to be listening to you all the time. They only wake up when they hear the wake up call, and then they activate the microphone and connect to the cloud. They can whatever you say to them and send it to the cloud and start processing. But after that it shuts down again. Only when you say the wake up call, it activates and wake up and starts interacting with you. Voice print recognition is the ability to recognize certain voice. So each one of us has his own voice print. It's like your fingerprint, and the device has the ability to recognize which individual is talking to the device using his voice print. Audio-based incident detection is similar to the wake-up call. You set the system to recognize certain sounds, to activate certain tasks, or to do something specific when it hears certain sounds or voices. Voice recognition is the most mature technology. It can achieve up to 96% accuracy in quiet indoor environments. Voice processing application scenarios. One of the application scenarios for voice processing is the dictation. In Microsoft Word, you can use the dictate to just talk and it will start typing for you. You don't have to type yourself. This uses speech recognition or speech processing. Another example is Alexa and Siri. But actually Alexa and Siri and Google Smart Home, all these devices has both speech recognition and also NLP. Automatic speech recognition and NLP. To function properly, they have both of them. They integrate both fields to give the final product. I will go through NLP first and then go back to Siri and Alexa to explain the process and what does NLP do and what does speech recognition do for both of them. So for natural language processing research, it covers machine translation like Google. This is done using NLP, text mining, and sentiment analysis. Sentiment analysis is recognizing or classifying the text or the word like a statement. Then it will extract the sentiment out, the emotions inside the statement. Is it positive? Is it negative? Is it angry? Is it happy? Something like that. Challenges used to include technical difficulty and immaturity. So this info is a little bit outdated. It's funny how that even though the course has been updated recently, it still can't catch up with the development in AI. Up to recently, just a year ago, before the breakthrough that happened in ChatGPT and large language models, NLP used to be the least advanced field in AI. It had a lot of difficulties and there was like challenges to achieve deep understanding and full ability to understand human language. In the past, the development was about progressing from shallow semantics to automatic feature extraction and deep semantic understanding. This has already been achieved by large language models, large LLMs, large language models. ChatGPT is a large language model. Also there's Claude and there are many players in the field currently. Large language models were the breakthrough that happened in NLP to overcome the challenges that used to persist in the past. Some NLP application scenarios. Sentiment analysis is one of the application scenarios of NLP. Extract public opinion analysis, emotion analysis, and opinion extraction for understanding user comments. So it goes like this. Here we have an example of NLP. You have a movie and the movie has reviews. You analyze each review to understand the sentiment behind it. So the first review is like the movie is boring, and you use the model to get inference from the review, and the result is negative comment. So let's say the review is the movie is fantastic. It would have been positive comment. Other applications are also intelligent copywriting, text classification, machine translation, and customer service chatbot. Intelligent copywriting is about using the AI and the generative AI especially for writing articles and journals for any other use you want. So it uses the AI to write about topics and articles
Text classification is similar to the one used in Google Gmail, the mail. It classifies the emails based on the text and other features into spam and non-spam. So using AI, they detect spam and lock it away in the spam folder. Machine translation, already covered this one. This is like Google Translate and other automated translation. Customer service chatbot. I think we are all familiar with this one. Is the chatbot that you interact with as soon as you arrive at most of the customer service website nowadays, like Amazon and other shopping websites. You hit the customer service. First you get a chatbot that gives you some answers, and if it can't answer you, then you get redirected to a human agent to answer you. So let's talk about smart assistants. I said before that smart assistants have both voice recognition and NLP. So how do they work? They hear you, receive your talk or your command, whatever you say to them, they analyze it, understand it, and do the command, and even give back feedback and talk to you and interact with you. So the way they work is like this. First you talk, you give a command in an audio version, sound, okay? They receive your command as a sound. So the first task is to convert it to something that a machine can deal with. For this, they use automatic speech recognition, which is voice recognition. The voice recognition engine, it converts audio into text. Okay? After it is converted to text, so it doesn't understand it like immediately. The first voice recognition, it only converts from audio to text, and then text is inputted into the NLP model or NLP engine. Okay, it understands it and convert it to a command, machine command in machine language, whatever it is. It does the requested command, and sometimes it will give feedback. It will generate a feedback. This feedback is then inputted into the speech recognition or text-to-speech engine. So the feedback comes from NLP as a text, and then it is converted to audio for you to hear back using text-to-speech. So you hear also audio. So let's explore some of the real-life applications. Smart mining. We'll start with smart mining. These are two examples that were given in the Huawei training material. So how to automate smart mining and improve the efficiency and safety in it. The mining chamber has critical devices. The goal is automatic inspection and unattended operation. What are the challenges? The chamber environment needs to be monitored 24/7, which means 24 hours, 7 days a week. And also periodic manual inspections are required. So what are the solutions? Solutions are to monitor it and inspect it using AI, using vision and sound. Machine vision based video surveillance for 24-hour monitoring of sensitive areas are used. The cameras not only capture the image but also analyze it using AI and take decisions and actions. Also sound detection, AI sound detection techniques to intelligently monitor the devices and the environment inside the machine, inside the mining area, the mining chamber. Sound also monitor all the sounds inside the mining chamber, yes, and it analyzes the sounds and transfer it to meaningful inputs and data for decision making. Another real life application is the Nature Guardian project. This is a project done by Huawei in Chile to protect the Darwin's fox. It's an endangered species. So the Nature Guardian project uses AI to protect the Darwin's fox in Chile's Nahilputa mountain range. I hope I'm pronouncing it right. So it uses solar devices with microphones and antennas to collect sound data, identifying threats like gunshots and illegal activities. Trained AI analyzes sounds, helping study species distribution and behavior for effective environmental protection. Let's answer some questions on the previous part. The current technology application directions of artificial intelligence mainly include. The question is asking what are the main fields of AI? Natural language processing, control system, computer vision, speech recognition. So this is a multiple choice question. As I said before, if the choices have a square in front of them, then it's a multiple choice. You have to choose, or you can choose more than one correct answer. If the choices have circles in front of them, this is a single choice question, and it has only one correct answer. This is the style of Huawei HCIA-AI exam, and I'm following the same style here. So to answer this question, what are the main directions, application directions in AI? As we said before, there are three: natural language processing, computer vision, and speech recognition. So we have three. You have to pick all three correct answers. Which of the following is not an application of speech processing? One correct answer. Which is not an application of speech processing? Speech recognition, or text-to-speech, or voice print recognition, or named entity recognition. So speech recognition, it is an application of speech processing, and text-to-speech is also an application of speech processing. Voice print recognition is also an application of speech processing. The only one here that is not an application of speech processing is named entity recognition. What is named entity recognition, or NER for short? NER is a technique used in NLP. It recognizes the certain words in the text or the sentence. So for example, let's say you have a sentence like this. Okay. Say Elon Musk founded SpaceX, and Jeff Bezos founded, let's say, Amazon. Okay, so named entity recognition will extract the first one, Elon Musk, as person, and SpaceX as an organization or a company. Also the next
sentence, it will recognize this as a person and recognize Amazon as an organization or a company. And you can control the names of the entities, organization, person. You can add company. Based on the task that you want to do, you can assign it the entities that you want to classify the text into or extract from the text, and do it using NER. I advise everyone who wants to start at NLP to look at NER and start a project or two using NER. It's quite easy and it's very useful, especially for to develop your techniques for using keywords and simple NLP projects. I personally recommend this to be the first project that you do for NLP to start your learning journey in AI. Also, I think it's better to try to do it manually using keywords and certain parsing techniques, using string techniques and parsing techniques without using any machine learning algorithms or artificial neural network or any machine learning at all. Just do it manually first to get your hands dirty with the way that sentences are comprised together, and to understand the process of parsing texts and like that. And then use some machine learning algorithms or machine learning libraries. One of the most famous one and the best one is Spacey. Spacey is an NLP Python library. You can use it for NER or other NLP techniques, and it will make it easy for you. But first, I prefer that you do it manually to understand the process of NLP. Now choose all the correct answers. Which of the following are AI subfields? Machine learning, computer vision, speech recognition, and natural language processing. Yes, the correct answer is all of them. Machine learning is a subfield of AI, also computer vision, speech recognition, and natural language processing. The next question is true or false. Voice recognition refers to conversion of audio data to text data. Is this true or false? Yes, this is true. Voice recognition refers to the conversion of audio data to text data, and also from text data to audio data. Now choose the correct answer. Which of the following is not an application of image recognition? Target detection, smart photo album, scene analysis, or speech synthesis? Of course, we said target detection is the use of image processing to recognize target in the photo or video. Smart photo album is also an application of image recognition, and also scene analysis. The only one that is not an application of image recognition is speech synthesis. Choose the correct answer. According to the American Society of Automotive Engineers, SAE, the automatic driving is divided into which level? L1 to L4, level 1 to level 4, or level 1 to level 5, or level 0 to level 4, or level 0 to level 5. This info used to be in the first chapter in the training material of version 3.0, the older version, but it was removed in the newer one, 3.5. However, I still found this exact question in the mock test for 3.5, so I have included the question and I will explain what it means. So the SAE divides the automatic driving into 6 levels. They are 0 to 5. Level 0, 1, 2, 3, 4 and 5. 6 levels. Let's see what each level mean. The Society of Automotive Engineers (SAE) in the US defines 6 levels of driving automation, ranging from 0 fully manual to 5 fully autonomous. L0 indicates that the driving of a vehicle completely depends on the driver's operation. The system above level 3 can implement the driver's hand-off operation in specific cases, and in level 5 it depends on the system when vehicles are driving in all scenarios. So level 5 is fully autonomous and level 0 is fully manual. So the correct answer here is level 0 to level 5, 6 levels, 0 to 5. I advise you to pause the video with each question and answer the question yourself, then continue the video and see if your answer is correct or not. Don't just keep watching and listening. You should be active and try to answer the questions yourself before you know the answer. So this question is choose all the correct answers. Which of the following statements about some of the subfields of AI are true? Pause the question, pause the video, answer the question, and then come back to see the answer. Computer vision is a science that studies how to make computers see things. This is correct. So I will choose the first one. Speech processing is a general term for different speech processing technologies, such as the study of vocalization, the collection of statistics related to speech signals, speech recognition, machine synthesis, and speech perception. This one is also correct. So we have picked 2 up till now. Let's see the third one. Natural language processing (NLP) studies how to use computer technology to understand and use human language. This is also correct. The last one, autonomous driving does not require speech processing or computer vision. This one is incorrect. Of course, autonomous driving require speech processing and computer vision because speech processing will help the driver interact with the car, and computer vision is very essential for the car to see its surrounding and the cars around it and see the road. So at least computer vision is important for autonomous driving, and speech processing is also one of the technologies that are included for autonomous driving. Let's move to the next question. Again, pause the video, answer the question yourself, and then compare your answers. Which of the following statements about some of AI use cases are true? Smart home uses technologies such as the Internet of Things, IoT, and speech recognition. Correct. Smart healthcare uses AI technologies such as computer vision and data mining. Also correct. Smart city is a comprehensive domain covering all 3 basic technology fields of AI, such as speech, NLP, and computer vision. Also correct. Smart education features openness, sharing, interaction, collaboration, and ubiquity. It aims to modernize education and upgrade traditional teaching methods with information technologies. Also correct. The phases of AI, also known as the stages
of AI. The three stages of artificial intelligence include computational intelligence, space, and cognitive intelligence. Which is the third one? Weak artificial intelligence, perceptual intelligence, behavioral intelligence, or strong artificial intelligence. There are three stages or phases of AI, which are computing intelligence, perceptual intelligence, and cognitive intelligence. Each stage is more advanced than the previous one. In the computing intelligence, the machines can compute and transfer information as human beings do. Example of computing intelligence is the distributed computing and neural network. The benefits: it helps human beings store and quickly process massive data, laying a foundation of perception and cognition. The second phase is perceptual intelligence. In this phase, machines can listen and see, make judgments, and take simple actions. Examples are cameras capable of facial recognition and speakers able to understand speeches. The benefits of this stage: it helps human beings effectively finish work related to listening and seeing. The third and most advanced stage is cognitive intelligence. In this stage, machines can understand, think, and make decisions like human beings. An example of this stage is the unmanned vehicles enabling autonomous driving and robots acting autonomously. The benefits of this one: it fully assists in or replace partial work of human beings. Back to the question. The three stages of artificial intelligence include computational intelligence, which is the first stage, and perceptual intelligence, second stage. Then the third stage is cognitive intelligence. Another question on the phases of AI. Choose the correct answer. What is the performance of artificial intelligence in the stage of perceptual intelligence? Machines begin to understand, think, and make decisions like humans. Machines begin to calculate and transmit information just like humans. The machines starts to understand and make judgment and take some simple actions. Yes, this is the correct answer, which is perceptual intelligence is the second phase, which is a phase between the first, the lowest one, and the third, the highest one. Machines begin to understand, think, and make decisions like humans. This is the cognition stage, the third one, the most advanced one. And then machines begin to calculate, transmit information. This is the first stage, the computation intelligence. And perceptual intelligence is the one in between. Machines start to understand and take simple actions. How does AI perform in the cognitive intelligence phase? Machines begin to compute and transmit information like humans? No, this is the first one, computational phase. Machines begin to see, listen, understand, and make judgment and take simple actions? No, this is the second stage. Machines begin to understand, think, and make decisions like humans? Yes, this is the cognitive intelligence. Let's see the last choice. Machines begin to record information such as pictures and voices. Also, this is the first stage. So the correct answer is the third choice. Machines begin to understand, think, and make decisions like humans. That was all for today. Thank you for attending today's class at 591 Lab. We hope you found the material informative and helpful. And remember, practice is critical to mastering any new skill. So review the course content and keep practicing with 591 Lab help and support. If you have any questions or concerns, please don't hesitate to contact us.
We appreciate your participation and look forward to seeing you in our future classes. Have a great day.